We know how to multiply two rational numbers. But what if we have more than two rational numbers? Like in this problem, we have four rational numbers. Now, we can solve this in two different ways. First way is using the property of associativity of multiplication of rational numbers. Associativity. And we have discussed all these things, right? Associativity. So it means if we have, let's say we have four rational numbers, a times b, c, and d. A, b, c, d are four rational numbers. Then we can pair it like this: a times b times c times d. Okay, we can pair it like this. This is associativity. So same thing we can apply here. We can apply here and we can like do this 1 over 4 times 2 over 3, then times 9 over 6 times 5 over 2. So if you solve this, you get 1 times 2 divided by 4 times 3 times 9 times 5 and 6 times 2. So solving this, we get 2 over 12 times 45 over 12. This gives you 2 times 45 and this is 12 times 12. You get 90 over 144. Right? So this is the answer when we follow the associativity path. Wait. There can be another way, that is simply multiply all the numerators together and simply multiply all the denominators together in one single shot. So 1 times 2 times 9 times 5 and then 4 times 3 times 6 times 2. In this case we get 2 times 1 is 2 times 9 is 18 times 5 is 90. 4 times 3 is 12 times 6 is 72 times 2 is 144. Now tell me, will you prefer this one or this one? Right? Clearly we can see that in this way to find the answer or the product, we simply have to multiply all the numerators together and all the denominators together. But in this case, you have to first pair and then you'll have to again multiply two rational numbers. So this is the much faster and smaller way, easier way. The question is, shouldn't we consider the associativity path, or what's the use of associativity path? Well, you'll understand its importance when you'll move to higher standards, and then when you'll solve complex problems, there you'll have to use associativity, commutativity and all. In this second problem, we have 1 times 3 over 7 times 2 times 9 over 11 times 6 over 5. Clearly, we have 5 rational numbers. Now, those of you who are thinking these are actually natural numbers, no, this can be written in the form of a rational number, right? We can divide by 1. Now, we have 5 rational numbers. If you follow the path of associativity, then this becomes 1 over 1 times 3 over 7 times 2 over 1 times 9 over 11 times 6 over 5. So if you're thinking that can't we write it like this, that is 1 over 1 times 3 over 7 times 2 over 1 then times 9 over 11 times 6 over 5. Can't we pair it like this? Of course you can, and answer is going to be the same. That is what associativity tells. Associativity of multiplication is you can associate or make pairings in different ways as you want, right? But the much easier way, simply multiply all the numerators together and then denominators together in one single shot. So 1 times 3 times 2 times 9 times 6, 1 times 7 times 1 times 11 times 5. 3 times 1 is 3 times 2 is 6 times 9 is 54. 54 times 6 is 6 4 24, 6 5 30 and 32, so 324, 6 9 54. Yes, and then 7 times 1 is 7, 77, 77 times 5 is 5 7 35, 3 5 7 35 and 385, right? So this is the answer for this one. You can solve use this in this way also, but it will take number of steps and you are going to get the same answer like we saw in this case.